In this example, we are going to find our impedance on Smith chart. So let's see what kind of impedance we have. Assume that we have impedance of 100 plus 100J, and we want to find this impedance on our Smith chart. So the characteristic impedance here is 50. So first, we have learned that we have to find the normalized impedance. So I'm starting from this point. My impedance, let's say it's Z1, and this impedance is equal to 100 plus 100J. So I have to first find my normalized impedance, which is simple. We said that the small z is equal to the Z1, the original impedance, over characteristic impedance. And this is going to be, if you divide this by 50, it's going to be 2 plus 2J. So this is my normalized impedance. In order to find this impedance, I'm going to do two steps. The first one, I will find the real part. The second one, I'm going to find the imaginary part. So for the real part, we said that we have to check this circle. So we have a circle here, and whatever impedance you choose on this circle, your real part is going to be 2. So this is the first. And how we can say it's 2? Because as you see, this circle, the intersection between this circle and this horizontal line is 2 here. So it means that 100 ohms. Another point is, now I want to go to imaginary part. So I want to find the imaginary part curves, or let's say lines. So in order to do that, it's very simple. I'm going to use this one. So this curve shows that whatever impedance I chose on this line is going to have the imaginary part of 100J, or you can say there are 2J if you want to talk about the normalized impedance. So after that, it's very simple. We are going to find the intersection of these two, basically the intersection of this curve and the circle. So what is it? It's very simple. I'm going to show it another color, actually. So let's show it green here. So this is going to be my impedance at this point, as you see. So here, and so this impedance is equal to 2 plus 2J. And if I want to find the real impedance, I just have to multiply it by characteristic impedance, and it's going to be 100 plus 100J. So as you see, it's simple. You can find the different impedances on a Smith chart. I suggest that you just practice this. For example, I can show you some points. Try to find the impedance here, for example, this time. So this time we don't know the impedance, but we know a point on Smith chart, and we want to find the impedance. And also maybe you can find somewhere here as well, somewhere here. So these 2 points, you can find this and practice this. So I'm going to have a homework, actually. You can also do this. It's going to help you to understand better and practice your Smith chart skills. So imagine that we have a network like this. There is a capacitance and resistance. I want to find the input impedance. So what is impedance? It means that here, this is going to be my Zn, or we can Zin, or we can call it ZAB, doesn't matter. So first of all, you're going to calculate this impedance, and I gave you the values. The capacitor is 1 picofarad, and resistance is 100. Frequency is 1 gigahertz. So after you calculated the impedance, the input impedance, so it's very simple. It's a parallel C and R, and you can find this. So we know that this is 1 over JC omega, and this is R, so the impedance is going to be 1 over JC omega parallel to R. So we're going to calculate this impedance, and imagine that the Smith chart has the characteristic impedance, this time 100. In the next section, we are going to talk about the reflection coefficient. So one of the advantages of Smith chart is finding the reflection coefficient. You can find it at load or at the input side. It's very useful, and we are going to discuss about that.